Stop. Stop. Okay. So today I'm going to be talking about weight, and the most important thing to remember about weight is that it's a force, unlike mass, which is a scalar. And in our everyday lives, we confuse these a lot because we say, or we exchange them, but in the scientific world, we need to remember that weight is a force, which therefore means it has size and direction, and mass is a scalar. So the definition of weight is a force that the Earth has on a mass, and it's also between masses. So in order to explain this force, we have two very important equations. The first is weight is equal to mass times gravity. And on Earth, the gravity is 9.81 meters per second, which is an acceleration. And we need to remember that when we multiply this unit by mass, we get newtons. So that's what we should be using for forces, and therefore weight, because it is a force. And the other equation that we need to remember is weight is equal to gravity, mass 1 times mass 2 over r squared. And this explains the relationship between weights in atmospheres other than Earth, and can help us explain weight between two objects of different masses. So in order to use this, we have to find the gravity. And if we're using it for Earth, that will be the gravitational force on Earth, which is, as I already said, negative 9.81 meters per second squared. And then the two masses will be what you're dealing with most of the time. Mass will be, mass 1 if you're using Earth, it'll be the mass of Earth, and mass 2 will be what you're measuring the weight of. But in a hypothetical situation where you're measuring the weight on a different planet or on the moon, you would use the mass of the moon, and then the radius is the distance between these two things. So that basically just explains weight.